Okay, so this is Quicksort, and the idea here is that you have mainly two key functions, partition and Quicksort. And what you do is that you pass an array, and it should be able to quicksort it into a result, right? So this is the pseudocode, and let's start over. So it starts always on Quicksort, right? And what it does is that it calls partition, which is here. And what partition does, you can see that you always call it with range, is that it finds the index here. And because this is not randomized, it's always the last element. And what it's going to do, or what's going to try, is to put all the elements that are smaller than the value at this index at the left side, and all the elements that are larger than this element on the right side. And then it will return the index that is going to, that the last element is going to be, okay, just call it midpoint or pivot point, right? It's going to find the resulting index in the array, the resulting index for the pivot point, right? And it's going to save it as Q, and it's going to run, now this is quicksort from this part and this part, so from the left and right. You can see here runs left and this runs the right side. So in an overview, it will be something like this, right? So you will run first quicksort, you will pick the last element, right? Then it will put everything that's smaller than this element to the left, and all the elements that are larger to the right, and then it's going to run from left, and left is going to do that here. You can see, do something like this. It's going to run from left, it's going to repeat the same. It's going to grab the last element, put everything smaller here to the left, everything that's larger to the right, and then you're gonna repeat that until everything is sorted, right? Something that's so small that is sorted. And the same here, right? This is, suppose this is sorted, and then it's going to run the same from the right side, right? Because this is always going to the left. You can see that this is kind of how it repeats, right? Right? So it finds left. If it's everything sorted, it goes to the next, and it quicksorts that. And here you can see some logs, right? So for example here, you can see that it picks 11 as a pivot point, right? At index 11, and then it's going to be swapping. The way that this works is that it's going to be swapping if the element is going to traverse each element on the array, and if it's less, it's going to be okay. But if the element is if the element is less, right, it's going to increase and it's going to swap. What does that mean? So you can see here that everything is okay. This is larger, but this is larger, and this is small. So if this is small, it's going to replace this with, and it stores it with the index I, right? So you can see the I should start as p-1, which is the pivot -1. The I should be pivot -1. Does that make sense? No. Right. So there was a confusion here? No. Pivot -1 is going to start at the pivot to R-1. R-1 is the right and left. Let's see here. So notice that the pseudocode is not that obvious, right? But you can see here that this should be correct. So you have the pivot, which is usually the last element, and then it's going to start at the start -1. Okay, now that makes sense. At the start -1, and it's going to go from the start to the end. And what it's going to do is that if the element found is lesser than the pivot, then it's going to increase I +1, which means that it's going to move it here, and then it's going to swap I and J, which means if the element is here, right, it's going to swap it by J. And notice that if start is 0, that means that I is here. So if this is J is less than pivot, then it's going to swap it in place. But if, let's say, you don't swap it in J here, but you're here, right, and I is here, so it's going to I +1, and it's going to replace I +1 and J, right? This is only if J is lesser. So let's go over the examples here. Now you can see that this is okay, but here, because this is larger, and once it finds something that's smaller, it's going to swap it with, it's going to increase I, move it here, so it's going to be I +1, it's going to be 0, and it's going to swap 9 and 13. And you can see here, swap 9 and 13, and you have 9 here. And it's going to do the same here. This will be 13 here, I can see 13, it's going to, starting from here, is going to find, oh, this is less than 11, and I is going to be here, it's going to do a +1, so it's going to select this one, and it's going to swap it, this one is going to swap it, so you can see the 19 is here, then the 5 is here, and it's going to repeat until everything that we have, so J ends up at 7, so it's 0, 1, 2, 3, 4, 5, 6, 7, right, which makes sense, and it's going to replace the element at 7 with 11, with the pivot, right? And you can see it here. This is the replace element, and the after. Oops, what happened? After partitioning, you hit that, and it's going to call after. Since the last element was 7, you have something like it's going to call the array on this one, right? So you can see that it's going to call from the left. And then the smaller part of the left, once this is sorted, right, you can see this should be what it returns, or the modification that it does, right? This and this stays the same because it doesn't check that, right? And then, yeah, it's going to continue until the entire array is sorted.